Good afternoon. Today we are looking at functions. So we'll start with linear functions. And the equation for a linear function is known as y is equals to mx plus c. And we know the m is the gradient of the line, c is actually the point where the graph cuts the y-axis. So which is normally the y-intercept value. So the 3 steps that you follow when you need to draw a graph, a linear graph. First, you write the equation in a standard form. Then you draw the graph, and then you determine the characteristics of that graph. So let's start with this example. So we've got 2y plus x minus 8 is equal to 0. So the first thing, we write the equation in the standard form, which is the standard form is y is equal to mx plus c. So let's try to put this one in a standard form. So we've got 2y, I'm gonna move the rest to that side. 2y is minus x plus 8. Then I'm gonna divide both sides by 2 so that I can have y as a subject only. So we've got minus half, 2 cancels 2, we've got minus half x plus 8 over 2 is 4. So that is the form. Then from here, you know your gradient is negative half and your c value is 4. The next step that you do is to draw a graph. But for you to draw a graph, you need to know the intercepts of that graph. So if we start with y-intercepts, that's where we set x to be 0. Then we've got our equation, which is minus half x plus 4. We set x is equal to 0. So we've got 0 plus 4. This becomes 0, therefore y is 4. Then our coordinate is 0 and 4. Then let's get the x-intercepts. That's where we set y is equals to 0. So if y is 0, we've got minus half x plus 4. So now we solve for x. So we can bring x this side, it becomes a positive number. So half x is equals to 4. Then to get the x, we can multiply by 2 on both sides. So we are left with x here. So then this is going to cancel. X is equals to 8. Therefore, the coordinates here is 8 and 0. Now we can draw our graph. So let's draw our graph. Now I didn't leave enough space for the graph, but let's draw our graph here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is x axis. Then we've got y axis. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. My graph is not up to scale, but yeah, you just have an idea. So we have our x-intercept, which is the first one. Our coordinates is 0 and 4 and 8 and 0. So 0 and 4, that's the first coordinates, then 8 and 0. 8 and 0 to be here. Therefore our graph is gonna look like this. Therefore this is our graph of y is equals to minus half x plus 4. So we've done the graph. Now the last step is to determine the characteristics of that graph, which means you get the gradient. Gradient we've already known, determined from the first step. Gradient is m, which is minus half. So gradient is negative half. Then the intercept is what we calculated, is 0 and 4 and 8 and 0. And C is 4. So those are the characteristics of a linear graph. So now we will move to the next function. The next function is a quadratic function. So with a quadratic function, we know the general formula for quadratic function is y is equals to ax squared plus bx plus c. So we are given the function is 2y minus x squared plus 4. So just like on the linear function, the first thing you do, you write the equation in a standard form, and this is the standard form. So let's do that. So we've got 2y is equals to, we bring this one to the other side, x squared minus 4. Then we can divide everything by 2 to get y to be the subject. Therefore, y will be x squared minus 2. So therefore, from the standard form, a is 1, b is 0, b is this form, so we don't have that, anything with an x. C is the constant, which is -2. So the this is half. Why am I missing that? So a is 1/2. A is 1/2 because this is half. I forgot to put that. So once you've got that, then you need to draw your graph. But for you to draw your quadratic or your parabola graph, a quadratic is actually for a parabola. So you need to determine the intercepts also. So let's start with y-intercepts. That's where we set x to be 0. So we've got y is equals to negative half x, positive half x squared minus 2, right? So if x is 0, 0 squared minus 2, therefore y is minus 2. So then already we've got 0 and minus 2. That's the first point. Then let's get x-intercept. That's why we set y to be 0 and find the values of x. So we've got y is equals to half x squared minus 2. Y is 0, then we determine x squared minus 2. So we can bring to this side, it becomes a positive. We're trying to make x the subject. Half x squared, then we can multiply by 2 for us to make x the subject. So we've got 4 and x squared. So x squared is equals to 4. Then for us to get x, we can put a square root on both sides. Therefore, x is plus or minus 2. So x is 2 or x is minus 2. Therefore, our coordinates is 2 and 0 and minus 2 and 0. Therefore, with this 3 coordinates, we can draw our parabolic graph or a quadratic graph. So let's do the graph this side. We've got 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. This is a 0. So we first have 0 and minus 2. 0 and minus 2, 0 is the value of x, and then y is minus 2. That's our first point. The other points that we have is 2 and 0 and minus 2 and 0. So on the graph, 2 and 0. 2 is x, 0 is y. Minus 2 and 0. Minus 2 is x, and 0 is y. So that's the other point. Then there we have our graph. There is our parabolic graph. So you've got your graph like that. Then, which is the graph of y is equals to half x squared minus 2. That's your graph. Then the last thing we address is to get the characteristics of the graph, which is actually you get the intercepts, which we have 0 and minus 2. We've got 2 and 0, and we've got minus 2 and 0. The next characteristics for a parabola is a turning point. A turning point. Turning point is where the parabolic graph turns. So the graph turns at minus 2 and 0. So turning point is 0 and minus 2. So it's turning at 0 and minus 2. So that is our turning point. Then the other characteristic is what do you call it? Axis of symmetry. Axis of symmetry. Axis of symmetry, the formula for the axis of symmetry is minus b over 2a. And our minus b we know from the first step, b is 0. So we've got minus 0 over 2, and a is half. To half. So 0 divided by any number is 0. So our axis of symmetry is actually 0. So then we've got that. The other part is actually its range and domain. So domain for this, domain is actually on the x-axis or on the x values. So the domain for this graph is actually any number, any real number on the x. So actually x is element of real numbers. Then range is actually talking about the y, whatever that is happening along the y-axis. So if we look at the y, because you can see on the domain, this graph, it can be any number on the x-axis, whether on the negative or on the positive, any number. This graph can continue go that way, continue go that way. So it's any number on the thing on the x-axis. That's why it's just an element of real numbers. Then the y, if you look at this, there's a turning point, so you can't have anything below this graph. So the y is actually where y is greater than minus 2, and anything above that minus 2, which means y is greater than minus 2 and y is the element of real numbers. So y is greater or equals to negative 2, and again y is the element of real numbers. And then the last numbers, the last function, someone is disturbing me, sorry. The last function that we are looking at is exponential function. So with exponential function, they will normally give you two functions to draw a graph of two functions, so you can be able to relate the relationships. So we're gonna do a graph where fx is 2 exponent x, and another graph where gx is 1 over 2 exponent x. So let's start with just like the other functions. We get the y-intercept. Y-intercept, you put x to be 0. So y is 2 exponent x. Then if x is 0, we've got 2 exponent 0. Any number exponent 0 is 1. So we've got 0 and 1. Then x-intercepts, it's where y is 0. I hope I'm right. So 0 is equals to 2 exponent x. So, and this you can't have a 0 equals to any number, so there is no solution on this one. Okay, then the next thing we do is actually to get the coordinates for this function in a table form like this, where we've got our y and we've got our x and the y. So we substitute, you just choose values on your number line. So we've got -2, we use -2, -1, 0, 1 and 2. So if x is -2, we put the value here. So we've got y is 2 exponent x, right? So we replace the x values there. So first one, if x is -2, so we've got 2 exponent -2, which is actually 1/4. So we've got 1/4 here. If x is -1, we've got 1/2. If x is 0, we've got any number exponent 0 is 1, so we'll have 1. If x is 1, you put 1 here, then we've got y will be 2. If x is 2, y will be 4. So we've got that. That's the coordinates for there. Those are the points for the graph y is equal to 2 exponent x. So okay, then let's draw that graph. We'll come back to the other one. So let's draw that graph. We've got 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, and -4. Same this side, -1, -2, -3, -4. This is 0. So the coordinates that the points that we have for drawing our graph, we've got 2 and negative 2 and 1/4. So x is -2 and 1 is y is 1/4. So that will be our 2 and 1/4. This is half, so 1/4 will be somewhere here. So here would be our first point. The next one is -1 and half. X is -1, y is half. So we've got x here, -1, and y is half. So we've got here. The next one is 0 and 1. X is 0, y is 1. So we have it here, our next point. The other one is x is 1, y is 2. So x is 1 and y is 2. So we have another point there. The last one, x is 2, y is 4. So we've got x is 2 and y is 4. So that is our hyperbola or exponential graph. So that is our graph. Let's do the other function that is given, which is gx is half x. We follow the same thing. So we do y-intercept. Y-intercept where we have x is 0. So y is equals to half exponent 0, which is 1. Therefore, we've got 0 and 1. Then x-intercept is where y is 0. So 0 is half exponent x, which is actually impossible. On this one, we've got no solution. Then from there, we go in again, do our little table and calculate. So it's x, it's y here. Our function is half exponent x. So we'll have our values -2, -1, 0, 1, and 2. So we're going to replace -2 here. -2. So we know actually half exponent x is the same as 2 exponent minus x, right? So half exponent x is 2 exponent minus x. So now we're going to replace. First, we're replacing -2 here. If we put -2 here, we're going to have 2 exponent -2, which is 1/4. Therefore, we're going to have 1 over 4 here. We replace minus 1, which gives us 1 over 2. 1 over 2. Am I right? No, let's see. Wait. It's a minus. Okay, I'm not doing it right. So let's start with minus 2. If we put minus 2 here, 2 exponent negative 2. Actually, we've got 2 exponent 2, which is giving. If we put minus 2, we've got 2 exponent negative and x is minus 2. So which is 2 exponent 2. Then you've got 4. Therefore, actually here, we've got 4, not that. Then if you put minus 1, same thing. So we've got the minuses cancel. If you put minus 1 here, you're going to have 2 exponent 1. Therefore, you're going to have 2 here, not the half. So you've got 2. Then we put 0. If we take 0 here, we put it 0 here, we're going to have 1. If we take 1 and put it there, you're going to have 2 exponent minus 1, which is going to give us half. If you put minus 2, not minus 2, if you put 2, you're going to have 2 exponent minus 2, which is actually 1 over 4. 2 exponent minus 2 is going to give you 1 over 4. Okay, so those are our points. Let's now draw the graph on this very same graph. Let's graph this one. So we've got minus 2, the first point minus 2 and 4. X is minus 2 and then y is 4. That's our first point. Next one, we've got minus 1 and 2. X is minus 1 and y is 2. So that's our next point. The next one is 0 and 1. X is 0, y is 1. X is 0, y is 1. So here, other one, x is 1, y is half. 1 and half. Then last one, x is 2, y is a quarter, 1 over 4. 2 and 1 over 4, which is somewhere here. Now we can draw our graph. Looks like that. So that is the graph of the hyperbola. Then we also determine the characteristics of this graph. We've got something called asymptotes. Asymptote is actually a line that the graph approaches, but it never reaches it. It's the line that the graph approaches, but it does not touch it. So you see this graph, which line are they approaching, but they never reach? The two of them is actually x is this x-axis, which is the line y is equals to 0. So asymptotes is actually line y is equals to 0, which is actually x-axis. Then the other characteristics of this is to be actually the y-intercepts. We do have the intercepts. Let's just call them intercepts. Intercepts, you've got for both functions, the intercept is 0 and 1 for the first one, and the other one, Leona, is still 0 and 1. So for both functions, the intercept is 0 and 1. And I think that's about it. Sorry about that disturbance. Someone requires attention somewhere. Thank you.